Hi, tonight's video is on point slope form. This is from lesson 5.4. Here are the standards that are listed. Here's a few of them written out for you and some of the I can statements that you'll be able to do as we work on this unit. If you need to pause to read through those and take a look, please do so. Some of the key things that you need to understand is that you can use slope of a line at any point to write a graph of an equation of a line. Any two equations have the same line are equivalent. So this other form, up to this point we've worked with slope-intercept. We are now going to fill into your notes point-slope form. And what point-slope form says is that for any non-vertical line with a slope of m, and it passes through a given point x1, y1, it is always y minus y1, that ordered pair, that point, equals m, the slope, times parenthesis x minus this point. It is always to a specific point, and it is always the difference, just like slope is the difference. So you got to watch this as we look for our solutions, and we're looking at where a line means. If the line passes through the point -3, 6, and has a slope of -5, first thing we want to think, well, what's our point? It's a -3, 6. Y minus our y-coordinate is 6, slope is -5, times parenthesis, x minus, our x-coordinate is a -3. Well, what happens if you have minus and negative? You get plus 3. So y minus 6 times 5 times the parenthesis, the quantity, x plus 3. Again, if you look at this point, first thing you want to start with is please write down your equation. Those of you sometimes think, I don't need to write this down. Put it on your paper to start your assignment. X minus x1. We're simply going to be substituting. Try it on your own, pause the video, and then restart it. As we are filling this in, our y-coordinate is -4. Equals our slope of 2/3, x minus our x-coordinate is 8. We do want to simplify this and not leave plus a negative, minus a negative, to y plus 4 equals 2/3 x times the quantity x minus 8. So what happens about graphing now? Well, before we always used our starting point, our y-intercept, and we used our slope. We're still going to use the slope. We just have to now identify our point, remembering that it is always y minus y1 equals m times x minus x1. So the question is, in this equation, 2 minus x minus 2 gives us an ordered pair of 2. Minusing 1 gives us the ordered pair of 2, 1, and a slope of 2/3. We want to put our first point over at 2, 1. From that point, we are going to go up 2 and over 3 to get another point. We could continue that with up 2, can't really go over 3, so I might go down 2 and back 3. Then you would draw your line. So, given the point and a slope, we can always graph an equation. Now it's your turn. We want to be thinking, what is our ordered pair first? Well, it's x minus 4, and it has to have a minus back here, so that has to be a positive 4. But we got plus 7. Well, remember, if you were going to rewrite that as a subtraction, it would be minus and -7. So our ordered pair is 4, -7. What is our slope? -4/5. We are going to start over at 1, 2, 3, 4, and down at -7. I think I did that right. 1, 2, 3, 4, 5, 6. One more down, -7. From this point, we are going to use our slope. Well, our slope was a -4/5. I can't go down 4 again, so I'm going to count up 4 and then back 5. Someone said, how do you know that you should go up? Remember, slope is rise over run. So positive 4, negative 5. We could do that one more time. Up 4 and back 5. And then we draw our line. And this is our graph. Can you write an equation for a line given any 2 points? First, use the 2 points given and find your slope. So if you're only given 2 points, and we want to write it in slope-intercept form, it looks like it's somewhere between 1 and 2. So if we want to do this, first thing we want to do is write our equation for slope, and we're going to subtract those points. Again, you're filling this in on your notes. Next thing we want to take a look at is subtracting our y coordinates. So we have negative 3 minus 4 over negative 2 minus 1. We are going to get a negative 7/3. Not an easy slope. Could you have also counted up 7? In this case, over 3. You could have done that also. We now want to put it in point slope form because slope intercept would be a little ugly at this point. Getting some ugly fractions for our numbers. So we use one of our points. We're going to use the point 1,4. So if I'm substituting in y minus 4, 7/3, x minus 1. Oh, what if someone else said, you know, Mrs. Thompson, I was looking at this assignment and I used the point negative 2, negative 3. If they use negative 2, negative 3, we're going to have y minus, our y coordinate would be a negative 3, becomes y plus 3. 7/3, still our slope, times x plus 2. So either one of these two equations would be correct as you would be putting this down. You'll usually see one that they'll tell you to use 1 point, but if they don't tell you, either one would be correct. If we are going to use a table to write an equation, again, in this one we're talking about the time in seconds that an air balloon is descending. As we look at the equation, slope-intercept form is asked, but we want to probably start with point slope. If we are looking at this, we're going to use two of our points, 10, 640, and 30, 590. The first 2 points, we find the change. Our slope is a negative 2.5. We are now going to plug in our points. If we use our data point, 10, 640, we're going to plug in y minus 640 equals 2.5 times x minus 10. Now, if we are solving this, remember, in slope-intercept form, we would want to use the distributive property, 0.25x, and then we would have a plus 2.5 times 10 would give us 25. And to get y by itself, we'd add 640, so our new equation would be y equals negative 2.5x plus 665. What is that telling us? The slope tells us that it is descending at 2.5 seconds, meters per second, and our y-intercept is that it started at 665 meters. It is now your turn. Here is the volume of a water tank in hours, 2, 3, 5, 8. The water is filling up with gallons of water. 3,320 gallons, 4,570. So this table, we are asked to write, if the relationship, and we know this relationship is linear, what is an equation in point slope form that will model it? So look back at what we just did in the last example and try this one at this point. I know you guys can do it. We'll be ready for tomorrow. See you in class.